Hello students. So in the previous lecture we have studied that how the energy or how the energy levels are distributed in the rotational energy spectra. We have also studied the formula for energy, that is Ej is equal to h upon h square upon 8 pi square I into bracket j into j plus 1 centimeter joule. Okay, so this was the formula for the energy. So now the next is to convert it into the wave number, that is epsilon j. It was h upon 8 pi square IC to j into j plus 1, and the unit is centimeter inverse. So this we have studied in the previous lecture. Okay, the next point is that we have studied, that is selection rule. So the selection rule tells us that delta J is equal to plus minus 1 are the allowed transition. So according to the selection rules, the change in which delta J is equal to plus minus 2 or plus minus 3 or onwards was forbidden. Okay, this was forbidden. So what does this means? The transition probability for all these changes is 0. Okay, that means there is no probability that this change will occur. And opposite to this, when delta J is equal to plus minus 1, that means the J changes by only 1 unit. For that, almost all transitions are equally likely to occur. So what does this mean? That all the transitions in which the delta J or the change in J is plus or minus 1, that have an equal probability, whereas the one having delta J plus minus 2 or plus minus 3 has the 0 transition probability. Is it okay? So this is the main point. So as we have said that they have the equal transition probability, but it does not mean that all the spectral line will be equally intense. Okay, so as we know that the transition probability is similar, they have equal transition probability, but it does not mean that the intensity of that spectral line will be equal. So the intensity of spectral line will be different for each of the transition. So on which criteria does it depends? It is given by Boltzmann Distribution Law. So which energy level will be how much intense it is given by the Boltzmann Distribution Law. Is it okay? So, according to this, what happens or what is the formula that Nj upon N0. So, what does this Nj and N0 indicates? Nj is the number of molecules in the jth energy level, whereas N0 is the number of molecules present in the J is equal to 0 energy level, and that is given by exponential of minus Ej upon Kt. Okay, so now here we know the formula of Ej, that is minus Bhc upon Kt. So where Nj is what? Number of molecules in jth energy level, and N0 is number of molecules in J is equal to 0 energy state or energy level. Is it okay? Where K is the Boltzmann constant, T is the temperature, B is the rotational constant, okay. So, when the scientists have calculated the value of B, approximately that value comes to be equal to 2 centimeter inverse. Is it okay? It is 2 centimeter inverse. So, for example, we are taking, okay. For example, if the value of B is equal to 2 centimeter inverse, we will calculate the relative population of J is equal to 1 energy level. So, I will take here example. So, for the molecule where B is equal to 2 centimeter inverse, okay. So, now we know that Mj, that means N1, we are calculating for the J is equal to 1 upon N0 is equal to exponential of minus 2 into the value of H is 6.63 into 10 raised to minus 34 into C, that is 3 into 10 raised to 10 upon. So here we have forgotten one thing. Please note it. Exponential of minus Bhc J into J plus 1 upon Kt. Okay. We have forgotten to add J into J plus 1. So now we are taking for J is equal to 1 into J plus 1 is equal to upon this Kt, that is 1.38 into 10 raised to minus 23 into temperature 300. We are taking the room temperature in the Kelvin. Okay. So, this whole calculation comes to be equal to exponential of minus 0.0019, and which is equal to 0.98. So, by using this formula, we can calculate the relative probability or the relative population of energy level. Okay, so have you understand this formula? Okay, the next part is the formula for most populated energy level. The most populated energy level. So how can you say that the J is equal to 1 is the most populated level, or the J is equal to 3 is the most populated energy level? So this can be found out by using the formula that J max, that is the most populated energy level, is given by under root of KT upon 2hc into P minus 1 upon 2. Okay, so this is the formula for the most populated energy state. Is it okay? So this was for the population of energy level and also for the probability of that energy level or the relative population in that energy level. The next point that we are going to see, the effect of isotopic substitution. So what does this isotopic substitution means? So when a particular atom in a molecule is replaced by its isotope, then a molecule or the element is identical in every way except in atomic mass. Okay, so what does this mean? So talking about the isotopic substitution, when any of the atom present in the molecule is replaced by its isotope, then the whole molecule remains the same. But what changes? The change is the atomic mass. Okay, so what will happen? There will be no change in internuclear distance. Okay, by isotopic substitution there will be no change in the internuclear distance. The only change is in total mass. Okay, and due to which the moment of inertia, we know that the moment of inertia is equal to mr square. Talking in the simple, that means it depends on the mass. As the mass changes, the moment of inertia also changes, and therefore the value of rotational constant also changes. Okay. So when there is an isotopic substitution in a molecule, what happens? There is no change in the internuclear distance, but there is a change in total mass, and therefore there is a change in moment of inertia. And as there is a change in moment of inertia, there is a change in the rotational constant B. Is it clear? So here I will take an example of carbon monoxide. So see, so the first carbon was carbon 12 O16, but it changes to carbon 13 and O16 as it is. So as it changes from carbon 12 to carbon 13, there is increase in the mass. Okay. So for carbon 12 O16, the B is the rotational constant, and for carbon 13 O16, we will denote it by B dash. Is it clear? So as there is a increase in the mass, there is also increase in the see, as the mass increases, we know that B is equal to H upon 8 pi square I C. We also know that H upon 8 pi square I, that is mu R square C. So as the mu changes, that is as the reduced mass changes, the value of B also changes. But you must remember that B is inversely proportional to this mass. Okay. It has the inversely proportional relation. So that means B will be greater than B dash. Is it clear? And this change is reflected on the energy levels. Okay. So this is the diagram for the effect of isotopic substitution on the energy levels and the rotational spectra of diatomic molecule such as carbon monoxide. So these are the energy levels for the carbon monoxide having carbon 12. And these are the energy levels for the carbon monoxide having carbon substituted by carbon 13. So what happens as the value of B is greater than value of B dash? So these energy levels are said to be precise or extremely low for the substituted carbon monoxide. Okay. That means the energy levels are lower. The spectrum of heavier species will show a smaller separation between the lines than that of the lighter one. Okay. You have to remember the sentence. The spectrum of the heavier species will have the smaller separation between the spectrum line than that of the lighter one. That means as the molecule becomes heavier, so here you can see, as the molecule becomes heavier, the separation between the spectral line becomes lower. That means they are they will have very small separation, but the one which is lighter will have a greater separation in the spectral line. Okay. So here the scientist Gilliam has observed that the first rotational absorption of carbon monoxide having carbon 12 to be at 3.84235 centimeter inverse, while for carbon monoxide having carbon 13 at 3.67337 centimeter inverse. So when we calculate the value of B, we get B is equal to 1.92118 centimeter inverse, and the value of B dash is equal to 1.83669 centimeter inverse. So now we will take the ratio of B upon B dash, which is equal to H upon 8 pi square IC into 8 pi square I dash C upon H. So everything gets cancelled. Remains what? I dash upon I. We know that I is equal to mu r square. As the internuclear distance does not changes, so what will be there? Mu dash upon mu. And this ratio is equal to 1.046. So mu is the reduced mass. So this implies that B is greater than B dash. This is the proof that B is equal to 1.046 into B dash. So therefore B is greater than B dash. Here we have taken an example of carbon monoxide. Is it clear? Okay, so here we will stop. Thank you.